Welcome friends. In this video, we are going to see how to solve problems depending upon inverse Laplace transform by using properties. Today, we are going to start with the property differentiation in case of inverse Laplace transform. So this is the property. This property states that Laplace of derivative is nothing but minus t upon t. Just see what is the Laplace transform of t into f of t. Effect of multiplication by t. So Laplace of t into f of t becomes minus phi dash and therefore we have prepared inverse Laplace transform property. So now how to solve problems and what are the typical problems depending upon this. So this example is taken. I will solve 2-3 examples depending upon these properties. So try to understand how to identify the property. Directly we cannot find inverse Laplace transform because there is no formula with respect to log. Okay, so we convert log into simpler form. Okay, that is called standard form. Here, solution phi s is equal to log into bracket s plus a divided by s plus b. To remove log, we differentiate this. So phi dash of s means derivative of log. Before that, we simplify this log of s plus a minus log of s plus b. That is what is logarithm of log of m plus log of m by n. See this, log of m by n equals to log of m minus log of n. So this is what is the formula. Okay. So phi dash s becomes 1 upon s plus a minus 1 upon s plus b. And then we take inverse Laplace on both sides. So we get phi dash is equal to L inverse into bracket 1 upon s plus a, and here L inverse into bracket 1 upon s plus b. So this value is replaced by property L inverse phi dash is minus. So immediately we write minus t upon t. And here L inverse is e raised to minus at. This is standard formula. And this is also e raised to minus bt. But we want f of t because f of t is supposed to be inverse of phi. Okay. And therefore, here f of t is equal to minus transfer 1 upon t because t is multiplied. Here we write minus 1 upon t into bracket e raised to minus at and e raised to minus bt. To stop. Or we may write like this, e raised to minus bt minus e raised to minus at divided by t, that is absorption of negative sign. Okay, so this is what is the solution. So in this problem, what you have to do basically, if inverse Laplace is asked and if it is not in standard form, say log, there is no formula with log, and therefore we do by this property. So one more example we are going to consider of this type. Now suppose we are asked to evaluate inverse Laplace transform tan inverse. Yes. So in this case, tan inverse S is also not standard form. Okay, so solution. or a square plus 1, and then we take inverse Laplace transform. So phi dash is equal to an inverse into bracket 1 upon a square plus 1. So this is replaced by minus t upon t as before. This formula is used here and equals to, this is standard formula for sin t. This is very important. See what is basic. Basic is inverse Laplace of a divided by a square plus a square, or we may write 1 upon a square plus a square is sin a by a. This is what is the inverse Laplace formula. So f of t we are equal. So f of t is equal to minus 1 by t into sin t, or we may write sin t by t. That's all. So this is what is the second problem depending upon same property. What is the property? An inverse of phi dash, directly or not given phi dash. You have to consider the quantity inside the bracket to be phi, not phi dash, right? And then we consider this inverse of phi dash is equal to minus t of t. This is what is the basic formula. So one more example we are going to see. Second example, or third example. Evaluate this. What inverse of s by 3? Then we write like this. S is equal to what inverse s by 3. Then we differentiate. Derivative of cot inverse, here we write derivative d by dx of cot inverse x by a. The answer comes minus a divided by x square plus a square. This is what is the formula for cot inverse. And therefore, using that formula, here we write minus 3 divided by a square plus 3 square, that is 9. And we take inverse Laplace of this. So we get phi dash s is equal to L inverse into bracket minus 3 divided by s square plus 9. And which is same as minus 3, or negative sign we can take outside, and then what we get is L inverse into bracket 3 divided by s square plus 9, and which is nothing but standard form number 2. So it is equal to minus sin 3t. This is what is L inverse. But now we replace this value by minus t into f of t at the same time, and here also f of t. Negative sign we can transfer and we divide by minus t, and that answer comes as f of t is equal to sin 3t by t. Full stop. This is what is the third question. So what is the property? This is the property, L inverse of phi dash. But the property कधी वापरायची? In which situation we have to use this property? ज्यावेळी तुम्हाला स्टँडर्ड फंक्शन दिलेलं नाही त्यावेळी तुम्ही ही प्रॉपर्टी वापरू शकता. आता प्रश्न असा पडतो की व्हॉट डू यू मीन बाय स्टँडर्ड फंक्शन्स. तुम्हाला जे फॉर्म्युले लिहून दिलेले 6 फॉर्म्युले 6 प्रॉपर्टीज, तर त्या 6 फॉर्म्युल्यापैकी हा फॉर्म्युला नसतो. फॉर एक्झाम्पल cot inverse is not there, tan inverse is not there, log is not there. One more example I will take, and then we proceed for further property. Suppose we are asked to evaluate again log L inverse into bracket log into bracket yes minus 2 divided by yes minus 3. What we have done is we have taken s minus 2 and s minus 3 as a and b. So solution here s is supposed to be log into bracket s minus 2 divided by s minus 3, and which is simple. Log of s minus 2 minus log of s minus 3 we can observe in first. So it is phi s, and then we differentiate. This is not derivative, this is simplification. So now differentiation 1 upon s minus 2 and here 1 upon s minus 3, and therefore taking the inverse we get answer phi dash s is equal to L inverse into bracket 1 upon s minus 2, and here minus L inverse 1 upon s minus 3. Just same as this is replaced by minus t upon t. This is very important, and here e raised to minus 2 plus 2t, sorry, and here minus e raised to 3t. Here we can observe negative sign is shifted, therefore we get f of t is equal to Now negative becomes positive, so we take a raised to 3t first, a raised to 2t later, and we divide it by t. That's the answer. Instead of a and b, we have taken minus 10 minus 3. So it's very particular case. That's all. This is what is about first property. So in this video, I will consider next property so that you can get 5 marks. Okay, depending upon properties of inverse Laplace transform. Okay. Suppose you are asked L inverse into bracket e to the power minus s and then is. Then what is the answer? The answer is f of t minus a into u a t. So what is this property going to be? So let us consider right hand side, this one. This is called unit step function. So that is UAT is nothing but curly bracket. Here 0 comes, here 1 comes. This is for t less and this is for t greater. This is what is called unit step function. So example may be asked like this. Find or evaluate L inverse into bracket e raised to minus 2s into s divided by s square plus 4. Problem may be asked like this. So if you are asked like this, then don't go to previous property, derivative property, because it's standard functions. Okay, so we don't differentiate or we don't use that property. That means differentiation property. It's a special property called as second shifting property. So here we observe that this a is equal to and phi s is equal to. See, a means power of a raised to e, that is 2. It's not minus 2, right? And phi s is equal to s divided by s square plus 4. Now remember, at once a is ready, phi s is ready. Take inverse here. Phi s is equal to a inverse into bracket s divided by s square plus 4. It's very simple. And then immediately we can identify formula. Here I am writing formula, say 3, 4 and 5. S divided inverse of s divided by s square plus s square. Can you recall? So what is this? Inverse Laplace of s upon s square plus s square comes out to be cos 80, and therefore this we write as cos 2t. That's not final answer. We have to put in this, and therefore L inverse into bracket a raised to minus twice s into phi s, that is s divided by s square plus 4, and now we can write this as f of t minus a. See, your f of t is this. This is called as f of t. And therefore, what is f of t minus a? That is t minus 2. And then into u. A is 2 and t. See what's going on. I am putting a is equal to this value. So which is same as f of t minus a. If it is f of t, then I will write cos into 2 into bracket t minus 2, because I have to subtract. I have to subtract 2 from t. Here there is t, so we can write inside the bracket, and then compulsory is multiplied by u2. This is what is the answer. You may stop here. On the other hand, you can write like this. If this value is considered 0 and 1, then it is common factor. If 0, then 0. If it is multiplied by 1, it comes cos 2 into bracket t minus 2. And here t is less and t is greater. Finish. This is what is the story. So by using this property, this means second shifting property in inverse Laplace transform, we can find out inverse Laplace of such functions. 5 marks साठी भारी प्रॉब्लेम्स आहेत, छान पैकी तयारी करायची. बट रिमेंबर फ्रेंड्स, बेसिक फॉर्म्युला आधी पाठ करा, नाहीतर तुम्ही वैतागून जाल. इन्व्हर्स लाप्लासच्या 6 प्रॉपर्टीज, लाप्लासच्या 6 प्रॉपर्टीज, लाप्लासचे पुन्हा अर्धा डझन फॉर्म्युले, इन्व्हर्स लाप्लासच्या अर्धा डझन फॉर्म्युले, हे असे 24 to maybe 30 you can first of all prepare, okay, until attack of the problems. Okay, next same question I am going to take for practice. Okay, you are asked to evaluate L inverse e raised to minus 3s, and here something more, that is say 1 divided by s cube or s raised to 4, say 7. Let me take 7. Okay, it's very simple. But now how to do? First of all, we put here a is equal to 3, and what is 5 is equal to 1 upon s raised to 7. So we take inverse Laplace of this. 1 upon s raised to 7. And we know that formula number 6. L inverse into bracket 1 upon s raised to n plus 1. This is basic formula. A raised to n upon n factorial. Okay, that formula we are going to use. 7 is compared with n plus 1. 7 is compared with n plus 1. If n plus 1 is 7, 0. Then what is 1? This is rough. Okay, that n is coming. Therefore, we will directly write e raised to 6 upon 6 factorial. Don't forget factorial. This is replaced by f of t, remember. And now, at once f of t is ready, we can put in the property. See what is the method of putting in property? We write L inverse into bracket e to the power minus 3s into 1 upon s raised to 7 is equal to f of t minus a. But here we write f of t minus 3 and then u3 and t. So which is same as this value is replaced by t minus 3. So t minus 3 raised to 6 divided by 6 factorial and then u3. You can stop here or you may simplify further. If it is multiplied by 0, it comes 0. If it is multiplied by 1, it comes as it is t minus 3 square divided by 6 factorial. And here conditions you have to put. T is less and t is greater, finish. So this is what is this story. Okay. So we have seen two properties. Okay. Can I take one more property? So in next video I will continue these properties. Thank you.